Alright, so we are revisiting the flags again here, and if we recall, these are all the flags that we have in the condition code register, but we are only talking about N flag, Z flag, V flag, and C flag, right? So we'll be just exploring some more things about the V flag today. So again, if you remember, in case of addition, if we add when the V flags are set, these are the conditions that when both numbers are positive but the sum is negative, right? Meaning if you are adding two numbers and both numbers are negative but the sum is positive, these are the cases when the V flag is set in case of addition. In case of subtraction, your top number is called minuend, the bottom number is called subtrahend, right? If you are doing the subtraction, and if this happens that subtrahend and difference have the same sign, meaning both of the subtrahend and difference are either negative or positive, but the numbers have different sign, right? You see the numbers have different sign, meaning one number is positive and the other number is negative, but subtrahend and difference have the same sign. Then these are the conditions that V flags are set, right? But one of the questions you might be asking yourself that some of the instructions, these are all about addition and subtraction, right? Now what happens when you have an instruction which does not do addition and subtraction? Because we have plenty of instructions, right, which is not about addition and subtraction, right? They do something else, right? So the question is, what actually happens when we have a different instruction, right? But we are talking about the V flag, meaning how the V flag is set, because the other flags we understand, right? We know that how the carry flag is set if you have a carry, right? If you have a negative answer, right, the negative flag will be set. If your answer is 0, the 0 flag is set. But how the V flag is set? Because the V flag, we talk everything about in terms of addition and subtraction, right? But if there is no addition and subtraction, in case of the other instructions, how the V flag is set? Now this is a good indication that if you have to deal with the V flag, the only way the V flag is set, if it is not addition and subtraction, be careful about this. If it is not addition and subtraction, the only time this flag is set when you check the instruction and your N flag and V flag, either of these flag is set. Okay? Look at this. This is what? Digital circuit class. What is this? Exclusive OR, right? Exclusive OR. Remember, the exclusive OR gives you high when any of the inputs are high, meaning C and N, they should have different sign. That means either C or N is set, not both, right? That means if anytime if you are dealing with an instruction which is not an addition, not a subtraction, but something else, right? Then if you find out that your C flag is set but N flag is not, then V flag will automatically set. Or if you find out that N flag is set but C flag is not, then V flag is automatically set. You see what I'm saying? This is for every other instruction where there is no addition and subtraction but V flag is affected. Okay? So be careful about this one. And also one more question, I think. One more question I think we also might be asking to ourselves, that because we have been talking about the flags for a while, and this might be a good question, that are the flags affected by every single instruction we have, right? See, we are talking about 4 flags, right? We are talking about C flag, Z flag, V flag, and N flag. The question is, are the flags affected by every single instructions we have? The answer is no. Okay? We have never seen this before, I guess, because the idea was that, oh, let's see, these instructions affect flags, this flag, that flag. But the answer is no, because all flags are not affected by all the instructions. Okay? But how do I know it? How do I know that which flags are instructed, which flags are affected by which instructions? How do I know it? To know this, we can directly go to the set of instruction, right? I think we all have the set of instruction, right? If you open it right now, you can find it. And we check the last 4 columns to know about C, Z, N, and V flags. Okay. Now let's look at, because I just pulled here two instructions. Yeah. I just pulled two instructions. I think we have used these two instructions in different quizzes, and also you'll be seeing in I'm sure in labs. Let's say I have one instruction here which is AND A, and another one is AND B, and as you all know that none of these instructions does addition and subtraction. These are binary AND, right? None of these are instruction addition and subtraction. If I go to the very rightmost four columns here, meaning the last four columns, okay, look at this. These are talking about N flag, Z flag, V flag, and C flag. So you will pretty much know all the flags, meaning it's a little bit about meaning how the flags are affected here. Because if you see a triangle symbol here, do you see there is a triangle symbol? Okay, little triangle symbol. That means flag is meaning this flag, meaning N flag is affected by this instruction. Affected means it might be cleared, it might be set. I don't know. I have to check and find, right? Affected means I don't know whether it might be set or cleared, but I have to check. Okay? That means by the AND instruction and A instruction, N flag, Z flag are affected, right? That means we don't know whether they will be set or cleared, but we have to check and find, right? What happens to the V flag? That means it's given that this instruction always clears V flag. You see what I'm saying? That means no matter what happens, if you run this instruction, V flag will be clear. You see what I'm saying? That's why it's mentioned 0. That means you don't have to calculate, you don't have to think, you for sure know that this will be 0. Okay? And if there is a hyphen like this, right, C flag, that means what? This flag, meaning C flag, is not affected by this instruction. Okay? That means we can now know that which flags are affected by which instruction. You see what I'm saying? So just looking at the last four columns. Okay? And I also wrote it here. Triangle means flag is affected by the instruction. Hyphen means flag is not affected by the instruction. And 0 means flag is cleared. Okay? Flag is cleared by this instruction. Now, let's look at one interesting example. I think we all have seen these instructions, so I'm not going over any addition and subtraction right now because I'm sure we know and we did some quizzes on these. Let's look at this example, okay? Now let's say what happens, because we have seen all the instructions and flags in terms of addition and subtraction. Now what happens if I have some instruction like this? Now look at this instruction. This is not the first instruction. This is a load instruction, right? We know this, right? This is a load instruction, and this means that you are loading C0, right? This is an immediate instruction, right? So you have the data here, which is C0. That means C0 is being loaded into accumulator B, right, by the first line. Now what happens in the second line? This is an arithmetic shift left, right? Remember, we also looked at shift, right? We looked at one quiz dedicated to the shift instructions, several shifting instructions, right? Now this means what? You are shifting all the bits of the accumulator B one bit left, right? This is exactly what happens here. Let's look at the operation. Now let's say this is your C0, right? This is C0 here. I wrote C0 here, right? This is your C1100, and this is 0. So that means C0 is loaded into accumulator B. But right after the second line, this is what happens, right? Everything moves to the left. That means whatever you have here, 1, that goes to the carry, and you actually pushed a C to the left side, right? This is what given in the column 3 of the ASLB, right? That means this is what we know from that column, that how these instructions work. You are actually basically pushing a C from this side, pushing a 0 from this side, okay? You are pushing a 0, and something will be popped out. Whatever you have, that will be popped out from the very leftmost column, right? First line. Look at the instruction, the first line, C0, right? I'm talking about this line. You see C0 here? That's what we had there, right? Look at this. This was C0, right? and then you pushed one, by the second line you pushed a 0 to the left side, and something is popped out from the other side, right? Now at this point, if somebody tells you, if somebody asks you what flags are set, because after the second line is executed, what flags are set, how do I know? Okay, now first of all, look at the carry flag. This is set, right? As you see, the whatever you have popped out, I'm saying whatever is popped out from the byte, that is actually stored into C, carry flag. That means carry flag is set at this case because the carry flag is 1, right? How about the number? Is the number is now negative number or positive number? Meaning whatever you have in accumulator B, is that positive or negative? That is a negative number, right? How do I know it? Just by looking at this bit, right? Because this is an indicator of the sign bit, right? That means this is a negative number, right? So that carry is clear because there is not, I'm saying, just looking at the 0, the 0 is clear, right? 1 is set. Okay? Now, this is exactly what is happening here, right? See, the negative flag is set because the number is negative, right? Whatever you have right now in accumulator, that is a negative number because the leftmost bit is 1, right? Oops. 0 flag, I'm sorry. 0 flag is not set. There is a typo, let me fix it. 0 flag is not set. Oops. Okay, I fixed the typo. 0 flag is not set because as you see, the number you have in the accumulator B right now is not 0, right? This is not 0, right? This should be a complete 0, right? So there is a 1 followed by 0, so this is not 0. So as you can see, so this is not a 0 flag will not be set, but the carry flag is set, right? Because you see there is a 1 here which is popped out from the byte, that is stored into the carry, so the carry flag is set. Now what happens to the V flag? As I said, in these cases, whenever you have an instruction which is not about addition, which is not about subtraction, which is something else, like this one, right? We determine V just by doing an exclusive OR between N and C, right? Again, exclusive OR. Now what happens? N is 1, C is 1 here, right? So V will be automatically 0 because the exclusive OR gives you high when any of the input is high. That means both of the inputs should be different, right? Either N or C is set, other one must be clear, right? If both are set, it will be 0. If both are cleared, it will be 0 as well, right? So just as a reminder. So we just have one more quiz left for the, I think, quiz 11, which is for the flags. That is actually the flag 2. I'm sorry? Yeah, because the V, what is the exclusive OR does? Exclusive OR gives you high when any of the inputs are high, right? Both of the inputs, either one is high. Both ones are high, so it's 0, right? Yes, yeah, exactly, yes. Again, recall from the digital circuit class, exclusive OR gives you high when any of the inputs are high. That means both of the inputs should be different. N and C both should be different, okay? One should be 0 and other should be 1. Then you will get 1 in V flag. Otherwise, it's 0, okay? So this, again, this is about when you have an instruction which is not about addition, not doing subtraction, but V flag is still affected because you should always check with your set of instruction to know whether the V flag is affected or not. It is possible that V flag is not affected, so you don't even have to work with that. Or it might be the case that is mentioned that V flag must be 0, right? I have shown you, right, in some, some instructions is given that V flag will be cleared, so you don't even have to work with the V flag. You just know that that's cleared, right? That's 0. Now we have one more quiz left for the flags, which is quiz 11, which is the last part of the flag, and we should be done with the flag then.